Hello, I'm Marco Fleck of Desert Star Systems, and this is a rough and ready tutorial about how files are stored on SD cards in the SonarPoint underwater acoustic recorder. This tutorial is for IT guys, so it's not really for end users, and the purpose is to get across to you how this works, because of course there can be a lot of investment going into doing underwater recordings, and you want to make sure that you can get them under all circumstances, and if something goes wrong you want to have some diagnostic capabilities. So here they are for you. The way we store data on SonarPoint is on these SD cards is not in a formatting of the cards that a Windows machine would recognize. Typically, SD cards are formatted in FAT32, and we used to do that, but then we had a very mission-critical application where losing data was just not an option, and it became clear that FAT, because the way it works, it stands for File Allocation Table, you have this daisy chain of different segments of a file, and if the directory gets corrupted, then you can't read your files anymore. That could happen if you had, for example, an unexpected power failure, and that wasn't an option. So we developed our own very simple file system, and that's what we're going to go over now, and how to have a look at that, how it's structured, and so on. To start with, here's a little hint as to once you recover a recorder from the water, how you can definitively tell what's been recorded on it. That's called the recording report. And in order to get it, you have to take your SonarPoint apart and connect it to USB, as I've already done here to save a little bit of time. Connect it to your PC, then go to a terminal program. I like to use TerraTerm. Make sure it's connected to the correct COM port, and also we are communicating here at a speed of 9600 baud, so make sure you use 9600 baud. You can find out which device you're connected to. This is number 2, so recorder number 2. These are what we call our dollar commands, so you just type, to get the report, you type the dollar and then the destination ID, so in this case 2, comma, your origin ID, and you can just use 0, that's really uncritical, comma, and then just RR for recording report. And there you see this report. Well, I should have the window a bit wider, and now my messages disappear. 0, comma, RR. I'm just going to do it again. All right, and let's look at this first, what we have here. So this is a mission report. It says from Micromar serial number 2. This was older firmware. I didn't say SonarPoint here yet, but it's the same thing for SonarPoint. You get the sample rate that you're recording at, the segment size. So these recordings were 10-minute intervals. You see the mission start time, 2019, April 17th. At this time, recording started at the same time. And then the recordings were done on May 4th. At this time, recording termination cause, in this case, was memory full, actually. All right, so down here we now see what's on the, in this particular recorder, had at the time 4 memory slots. It's really an in-house unit that I'm always changing around. So at the time I used it with 4 memory slots. 2 of them didn't even have a card in it, number 1 and number 2, so it's a bit unusual. You wouldn't usually do that, but I did that here. And then you can see that SD card number 3, recording ended at this time. There were 2,165 files on it, and the status is just memory full. So it went on to the next card, and then on April 4th, it did this, and then recorded well, it ended recording on the second card. We have 321 files in here, and the status was write failure. That doesn't have much anymore. Really what it was, the battery was getting empty, resulting in the SD card no longer being reliably accessible. We've changed that firmware since, so now you tend to see either a memory full or battery low, but you could still see a boot or a write fail at the very end. So, that's one of those things. Battery voltage goes down when you stop recording, getting the most out of each battery capacity, versus risking that you can't properly write to it anymore. So both of them are fine. But the key thing here is that you can now see there's definitely data on cards number 3 and 4 that were in your recorder. Just for a reminder how that works, here's your card slots, and the first one, they're actually not inserted here right now, but starting on this end is card number 1, 2, 3, 4, 5, 6, 7, 8. So 8 is closest. If you have 8 cards in your recorder, some of them have only 2, that's closest to your end cap here, the highest number. So now 100% data was recorded to that SD card because it takes a lot of interactions between the microcontroller here and the SD cards to write stuff to the SD cards, so that couldn't really happen if there was a problem with the card at the time of writing. So I want to emphasize that. So you would look to have something on card number 3 and then card number 4. I don't have these particular cards here anymore from back in May. It's October now. But now the next question is, all right, so normally you'd now read these cards with SP Reader or SPR. Do you have any options if that fails? If you somehow you can't read it, well, you can look on your cards with a hex editor. And what you do is you just take the memory card here, you plug it into a USB, and it should make this nice sound. And then you need to see this message here, where it asks you to format disk. And by the way, if you don't see that message, then your PC didn't recognize the card. So, for example, if you have a problem with SP Reader, make sure you really got this message and make sure you do not hit format. You don't want to overwrite it. What Windows is just telling you is it doesn't recognize the formatting. It's not a Windows standard. It's a standard for the SonarPoint recorder. And so therefore you hit cancel here. And now you want to look what's actually on the card and what should you expect to have on there. And what you can do is use a utility called HXD. This app, it's available free of charge on the internet, of course. Right-click on it to run as administrator so that you have enough privileges. Okay. Here we are. And now what I can do is I can go to Tools, Open Disk. Then I go to Physical Disks, and I select the one that I have. It happens to be this one. I have a 256 gigabyte card in there. It calls it here 238 gigabyte. Let me click on that. And here we go. This is in hexadecimal here. And we can inspect the individual sectors. Now, what should you expect to see? I'm going to show that here to you. So in the first sector, in sector number 0, you're going to see the what we still call the micromars file system. That was our first recorder. We ported that to SonarPoint, right? And then it says stored in sector 0, and these sectors are, or pages we sometimes call them. Here it says one SD card page is 512 bytes long. And the first thing you should see that will indicate to you that it's really a valid card is this fixed code, and it's 1776 1812. U.S. Independence Day and the War of 1812. So we use that as a memorable thing. And let's see if we have that here. Here we have it, 1812, 1776. See, you say, well, the numbers are flipped around. That's because, as an IT guy, you'll know that's because of the endianness. And this one is called little endian because it starts, strange terminology that they use, it starts with the least significant byte. So 18, 12, 12 is the least significant byte, 1776. So that would already tell me, okay, that looks to me like it's a validly formatted SonarPoint thing here. So then there's a version number, recorder serial number, and a bunch of other stuff. But the next thing that should happen now is you are looking for the file entry. And notice how down here it says the first file entry is at sector 16. And let me go back to HXD, and we are now at sector 0. Again, each sector is 512 bytes. I'm just going to go to sector 16. And here we are. Okay, this is my first file entry, my first recording here, but be that a 10-minute recording or whatever it is. And what do we expect to see here? Again, let's go back to our definition here. Okay, first 4 bytes, so it's unsigned long. It's 32 bits or 4 bytes for this machine. Start time in seconds since January 1st, 1970 UTC. So it's the Unix epoch time. Let's see if that makes sense. Let's see what we had here in HXD. Again, watching our endianness. Its time is 5CB6CEF0. I already entered that into a calculator. 5CB6CEF0 translates to decimal 15554844400. Now you can go to a Unix epoch converter. I already entered our number here, 15554844400, and it converted to me to say that this was April 17th, 2019 at 7 a.m. GMT or UTC. That makes sense. That's when this card would have been recorded. And so that looks like a valid file entry. There's other things in here. Here you see where the file is actually stored, what the starting sector is, the size of the file, the sample rate, a whole bunch of other stuff associated with it, you know. So that's all stored in your file entry, and then the next file entry would be in the next sector, in sector 17. And notice there's only always something here at the top, so most of the bytes are not even used. And there is, it turns out, 2 to the 20th file entries about, yes. So 2 to the 20th, so about 1 million file entries you can store. Be careful though as you use your SonarPoint recorder, even though the recorder can store, this file system can store up to 1 million entries per SD card. There's actually a limitation right now in SP Reader that it will only accept 1,000 files per SD card. So make sure your recording segments are long enough that you're not exceeding 1,000 per SD card. And of course, you don't want to have a massive amount of files. So it's good practice to do that. You may have to use a 1-hour file for some long endurance missions there or something like that. And that's all I wanted to show. Actually, there's one little thing. The recording report is stored on this device. It's not stored on the SD card, so that means you can read the recording report whether the cards are still in your recorder or not. I have to be a little bit careful. If you start up a recorder and it does have no cards in it, it keeps looking for a card. So, but the idea is that information is on the recorder, and then the data itself from the SD card, of course, is on the SD card. But what that means in terms of robustness is, let's say, even if an SD card was broken in half, you could still tell if something was recorded on it, because the recording report is on the recorder itself, not on the cards. So yeah, that's it for this demo. I hope that is of some use. And with that, best of luck playing with your SonarPoint, and have a good day.